Hello guys, hope you all doing extremely well. Let's continue our Blind 75 and dynamic programming series. Next problem here is unique path. Let's start the discussion with problem statement. What problem statement is saying? It is saying that we will be given a matrix m cross n. Will be given two values. हमें दो values as a input मिलेंगे m and n. Here m and n are representing a matrix of size m cross n. Suppose here we got m as 3 and n as 2. Then we have to consider a matrix which is having 3 rows and 2 columns. Let's make this matrix. It is having 3 rows and 2 columns like this. Okay. Now what we have to tell here, what we have to give answer here. We have to give answer as number of ways. How many ways are there? यहाँ पर कितने तरीके हैं, कितने ways हैं. अगर हम इस टॉप लेफ्ट सेल से स्टार्ट करें तो बॉटम राइट मोस्ट सेल तक पहुंचने के नंबर ऑफ वेज हमें बताना है, रिटर्न करना है. चलिए देख लेते हैं. अगर हमारे पास 3x2 की मैट्रिक्स है, 3x2 की ग्रिड है, कितने नंबर ऑफ वेज हो जाएंगे. एक वे ये हो जाएगा. और हाँ, यहाँ पर हम किस तरह की मूव्स कर सकते हैं. हम कर सकते हैं राइट एंड डाउन. 2 टाइप्स की मूव्स हम ले सकते हैं वाइल स्टैंडिंग ऑन अ पर्टिकुलर सेल. अब हम यहाँ पर स्टार्टिंग सेल पर हैं. मैं एक ले लेता हूँ राइट मूव, क्योंकि मैं ले सकता हूँ. और अब राइट नहीं ले सकता, आउट ऑफ बाउंड्स चला जाऊँगा. डाउन मूव. एक तरीका ये हो गया. नेक्स्ट तरीका, मैं यहाँ से ही डाउन मूव ले लूँ. देन राइट, देन डाउन. Let me make another path. Yes. So these are 2 different paths and 2 different ways of reaching end from starting. Now let's consider one more path. अगर मैं यहाँ से down and then right करूँ, then I will get one more path. So here total there are 3 ways of reaching the end from starting cell. तो इस केस में हमारा आउटपुट होगा 3. यही हमारे यहाँ पर एग्जाम्पल 1 है और यहाँ पर करेक्ट आउटपुट 3 है. कुछ इस तरह से. आई होप आपको प्रॉब्लम स्टेटमेंट समझ में आ गया होगा. चलिए इसकी अप्रोच समझते हैं. एंड विद अवर ट्रेडिशनल वे वी विल स्टार्ट विद द टॉप डाउन अप्रोच, रिकर्सिव अप्रोच. we'll take the same example. We have 3 rows and 2 columns. One thing we can do, it is the grid with us. We have to go from here to here, and we can also start from end and try to go till start, try to reach the starting point, and our moves will change. Now we can make left and up move, 2 types of moves, because we have changed the direction. Now we are going from ending to starting. All right, while doing the recursion. Okay, now I am making a move. Suppose I am making left move. So what it will change in the number of rows and column. If I am moving left, then the column number will be decreased by 1. It will become 3 1. And target here is reaching 1 1. इसका जो इंडेक्स होगा 1 1 होगा, क्योंकि मैंने यहाँ पर 3 और 2 से स्टार्ट किया है. अगर मैं लास्ट इंडेक्स 2 और 1 से स्टार्ट करता, then I would be trying to reach 0 and 0. But here I have taken the same indexes as the given m cross n. तो मेरा टारगेट रहेगा 1 क्रॉस 1 सेल पर पहुँचना. अब कॉलम तो 1 पर मैं पहुँच चुका हूँ, तो क्या कॉलम अब डिक्रीज़ कर सकते हैं? कॉलम डिक्रीज़ नहीं कर सकते हैं. इसलिए अब मैं लेफ़्ट वाली मूव नहीं कर पाऊँगा. मैं कहाँ पर पहुँच गया हूँ? मैं यहाँ पर पहुँच गया हूँ, यहाँ से यहाँ पर. अब मैं टॉप वाली मूव ही कर सकता हूँ, अप वाली मूव. चलिए अप वाली मूव करते हैं. अप वाली मूव से रो नंबर डिक्रीज़ होगा बाई 1. इट विल बिकम 2 क्रॉस 1 then after that it will become 1 cross 1. अगर मैं 1 क्रॉस 1 पहुंच गया तो एक हमारा वैलिड तरीका हो गया. यहाँ से मैं क्या करूँगा, रिटर्न 1 कर दूँगा. ये एक वैलिड वे है जिसको मैं काउंट करूँगा अपने फाइनल आंसर में. आई विल रिटर्न 1 फ्रॉम हेयर. और मुझे कौन सा पाथ मिला, मुझे ये वाला पाथ मिल गया. ओके, नाउ लेट्स एक्सप्लोर मोर पाथ्स. नाउ सपोज आई मेक अप मूव हेयर. दीज आर अप मूव्स. अगर मैं अप मूव करूँगा तो नंबर ऑफ रो डिक्रीज होंगे. क्या हो जाएंगी अब इस केस में? मैं यहाँ पर भी वही एक्सप्लोर कर रहा हूँ रिकर्शन से. एवरी वे ऑफ मूविंग अप एंड लेफ्ट, every combination. So here I've tried with making left move first. Now I am trying with making up move first. So I will get 1 and 2, sorry 2 and 2. यहाँ पे पहुँच जाऊँगा. Then can I make a left move here? Yes, of course I can make, because I haven't reached the column number 1 yet. Left up, I can make both the moves while standing over here 2 cross 2 cell. तो अगर मैं लेफ्ट मूव करूँगा तो क्या डिक्रीज होगा? तो डिक्रीज होगा कॉलम. आई विल रीच 2 and 1. एंड हेयर अगर मैं अप मूव करूँगा तो नंबर ऑफ रो डिक्रीज होगा. आई विल रीच 1 and 2. तो क्या मैं पहुँच चुका हूँ एंडिंग पर? नहीं. ये हमारा यहाँ पर बेस केस था और अभी मैं यहाँ पर बेस केस पर पहुँचने की कोशिश कर रहा हूँ. देन अगेन आई विल मेक 2 types ऑफ मूव्स. हियर आई कैन नॉट मेक, आई हैव ऑलरेडी रीच्ड द कॉलम नंबर 1. आई कैन नॉट मेक लेफ्ट मूव. So because if I make that, I will go out of bounds. I will make up move here and decrease. I will decrease the row number 1 1. This is the base case. I have reached here. I will return 1 from here. And from here, how many moves I can make? I have already reached the column row number 1, and I can only make left move, no right move. And while making left move, I will again reach 1 and 1, which is our base case. Again we have hit the base case, and from here also I will return 1. So I have returned 1 3 times. That I add up in the main problem. So here I will get 3, and here are our 3 paths: left up up, left up up, and other one is up left up up left up, and this path is up up left up up left, like this. So in this way I got 3 ways of reaching the starting point from ending point. I hope you understood this recursion tree and how we are going to apply recursion here. And you can also notice that here overlapping subproblems are present, so we can apply DP also, and we have to apply 2-dimensional DP because both row number and column number are changing here, so we need 2D DP table for memoization purpose of rows and column. Now let's try to code it with this approach, recursion approach, top down approach. We'll start with creating 2D DP table of size m cross n. Okay, vector of vector int, then DP, then m, then here each value will in itself will be a vector and its size will be n. Initially all values will be -1. Now after that I'm going to pass this dp and indexes to my recursive function m cross n then dp. Okay, now let's create this recursive function int sol int m int n then vector int vector of vector int a reference dp. What will be our base case? If m become 1 and n also becomes 1, it will be our base case and it will return 1 from here. We have already seen 1 and 1 is our base case. Now check memoization. As always, iteration if dp of m n is not -1, then it must be some valid answer. I will return that, which I have already calculated, and n. Okay, now I will make recursive calls. So first answer will be sol then m-1. I am decreasing the row, keeping column same as previous value, then dp, and I will check here if I'll put a check so that this m-1 don't result into an invalid index if m is greater than 1. Okay, so I must clear this above. Int 1 is equals to 0. Let's create 2 also here for storing the answer of the second call. If n greater than 1, then we'll calculate 2 solve n-1. Sorry, m will remain same, then n-1, then dp, like this. And in the end we'll return 1 plus 2 before inserting it in our dp table, like this: 1 plus 2, like this. This is it. And now let's try to run this. Okay, what happened? Okay, m and n are not present here. Okay, let's do +1. We have taken size as m and n, so these indexes m and n will be not present there. Largest index will be m-1 and n-1. So I've taken size as +1. Yes, now working as expected. Trying to submit it. Yes, got accepted. Now let's understand about its time complexity and space complexity. What will be time complexity here? See, it will be very simple. We have dp table of size m cross n. M cross n. How many cells are there? M into n. Hence we have to make recursive call for filling this cell once. After I filled, I will use my this dp table for if I again returning the answer if I get the same subproblem again anywhere. So I will be calculating this value for this particular cell once only. So how many times I will do that? N cross n times. So calling the recursive function is doing its work in order of 1. So I'm only making m into n recursive calls that will make its time complexity m cross n, and space complexity will be also m cross n because I'm using this 2D DP table. Alright, now let's move on to the next approach, tabulation approach. What I will do in tabulation, suppose I have this 3 2, so again I will create this matrix, and I know that if I am standing here, if I am already standing here means if there is only one cell and 1 cross 1, I'm already standing there, then there is one way of reaching the end. I don't have to go anywhere. This is also one way. So I will start like this. That dp of three minus 1, if 3 is there, or for m I can do like this, dp of, I will start with m minus 1 n minus 1 as 1. Then I will from this I will calculate the values of cells above it and left of it. Again I will do the same for this cell and this cell, and after that I will reach here and this will be my final answer. So here each cell is telling what are the number of ways to get there from the ending position. Now let's try this. Again 2D vector of vector in dp m n vector int n, and all values initially will be 0. Okay, dp of n minus 1 n minus 1 means for the last cell answer will be 1. Already standing at the last cell, and there is one way of reaching it. I'm only standing there where I have to go. So dp of m minus 1 and n minus 1 will be initially minus 1. Now let's calculate for other cells. So I will start from I is equals to m minus 2 I greater than is equals to 0 I minus minus, and similarly for column j is equals to n minus 1 2 minus 1 we have already calculated, is equals to 0, then j minus minus. Okay, but we have m minus 1 but we don't have m minus 1 and m minus 2 and n minus 1. So we'll start with minus 1 here and we will check later. I'll show you in a bit. So if I is greater than m minus 1, then what will we do here? dp of I j will be dp of I plus 1 and then j. Okay, so I'm here is the number of rows. What I'm doing, if I is here, it should be not greater than, it should be less than. If I is m minus 2, then m minus 2 plus 1, m minus 1, that is the last row. So we'll reach there like this. If I would not have placed this check here, it will come m minus 1, m minus 1 plus 1, that will be m. M is not valid index in m cross n grid. Okay, and for column also, if j is less than n minus 1, then dp of I j will be plus equals to, here I will put plus equals to because what we have calculated in this step, to that I will add this what I am calculating now. It will be dp of I and j plus 1. Let me show you here. This index is 0 0 and it is 0 1. The first value is representing the row number and second value is representing the column number. So if I am increasing row now, I will make it from 0 to 1, then column is still 0, then 1 1, and here it is 2 0 and it is 2 1. For 2 1 I know it is 1. It is matrix of 3 cross 2. I have already done this. 2 1 as 1. See here, I have done this. Now what I am calculating? I am calculating if I is less than m minus 1, means currently I was m minus 1. So I will not calculate this, I will calculate this. J is less than n minus 1, I will not calculate this also for the first iteration. Now when j will increase, it will become n minus 2, it is decreasing. So n minus 2 means second last column, it is this. I am calculating this. So here the row is m minus 1. So initially it is I think m minus 1 means, yes, last row. Here we are here in the last row and second last column we are calculating this. So what will be its value? It will be dp of I and j plus 1, same row and next column. Here we have placed value 1, so it will also become 1. Here 1 was placed. Okay, similarly when this j will run again, so it will come to an end, this inner for loop. Now this will decrease value, row number will decrease its value, and we will calculating this one next time. So it is now become from 3 to 1. Row is 1, m is 1 now, m is 1, and j is the last column. J is n minus 1 means 2 minus 1 1. We are calculating here, this will be I plus 1 j. So 1 will come, will also come here. and again we'll calculate this from the next column, but it is not present here. All right, then we'll calculate for this. It will be sum of this value 1 and this value. So after that, when this column will become 0, we'll be calculating 1 comma 0, and it will be I plus what is the value placed at dp I plus 1 and j. It is 1. It will be 1 from here, 1, this one will come here, and plus 1 from the next row, sorry, yeah, from here, and 1 from the next column, plus 1. It will become 2. And while we were calculating this, we'll use this 2, we'll calculate this. It will become 1, and for this 2 will come from here and 1 will come from here. It will become 3. So 3 will be our final answer. We will return 3 here. What we are going to return? dp of 0 and 0. All right, now let's try to run it. After placing return statement, okay, what happened? Yes, it got lost. Now let's return again. dp of 0 and 0, like this, and let's try to run it. Yes, working fine. Now let's try to submit it. Yes, it got successfully accepted. Now let's talk about time complexity and space complexity. So time complexity will be m cross n, because this for loop is running m number of times, and inside this loop is running n number of times. So time complexity m cross n, and space complexity also m cross n, as we have used this 2D dp table of size m cross n. All right, this is it for this video. I hope you like the explanation and understood this problem. If you are liking my channel, you can consider subscribing my channel, and take care. We'll meet in the next video.